and thought, memories to treasure, heavenly hourglass spinning at its leisure. We reach but we can't touch the hands that turn above, eternal in its motion, like the flight of a dove, ticking fast and ticking slow, a rhythm so divine in the heavenly hourglass. Our destinies align, counting moments in the sky, dreaming as we stare. Great cloud in the sky.
So in a previous video I showed that McToon and Pseudo the Science Guy Bob disagree with their own model, and I'll play a few clips of that, but unless they disagree with the laws of motion, then they would agree that to have an acceleration you must have a force. Basically what they have done is did a great job of debunking the globe model, and I will get into that.
You can't tell the difference between accelerating up versus if you're nearby a large mass like the Earth and not accelerating up. You can't tell the difference. That's the equivalence principle. It's not that the ground is actually rushing up. It's not that you're actually like moving upwards like the flat Earth society people think.
Well, no, the Earth can't be moving upwards.
The equivalence principle tells us that a uniform gravitational field is actually just an accelerating frame of reference. You and the ground beneath you are literally rushing up to meet the apple.
The apple doesn't hit Newton on the head because the Earth pulls the apple down. The apple hits Newton on the head because Newton accelerates upwards and headbutts the apple.
Are you watching this video in an inertial frame of reference? Well, I mean, do you feel weightless? No. So you are not an inertial observer. Your situation is exactly the same as someone accelerating on a rocket ship in deep space. And let me be clear, I don't mean that being at rest in a gravitational field is like accelerating in a rocket. I mean it is the exact same thing. You are accelerating and there is no gravitational field. Gravitational fields do not exist.
Gravity puts us in a non-inertial accelerated reference frame. And we have to say that the surface is what's being accelerated upward.
Is the true cause of apparent gravitational attraction. The fact that you're accelerating when you believed yourself to be stationary.
And since there's no force pushing down on you, that means you're currently accelerating upwards.
When you were sitting in a chair, you were quite literally being accelerated upward.
With Einstein's theory, the explanation is that they're not falling. It is the ground that is accelerating up.
So the only force on you are these normal forces pushing you up. So you are accelerating upwards.
Any deviation from inertial motion is a real acceleration. And real acceleration requires a real force.
So you heard him state that, and any physicist would tell you that any deviation from the inertial frame, which is the non-moving frame or constant motion frame, is a real acceleration, and real accelerations require a real force. That's the laws of motion. So I wonder if McToon and Pseudo the Science Guy disagree with the laws of motion now. So you heard it crystal clear, plain as day. MC Toon and Pseudo the Science Guy Bob saying that it's not the ground rising up to meet the apple. And I'm going to show how it can't be the apple being pulled down to the ground. It can't be a downward force or even a downward pseudo force. So if it's not an upward force, it's not a downward force, where does that leave the globe? Now I wholeheartedly feel like you guys are being deceptive, but just in case you don't understand, I'll explain it to you. When dealing with Newtonian gravity, the inertial or non-moving frame is at rest on the ground. You have a certain amount of weight depending on the size of the big mass and your distance away from it. When you're on the ground, you're in the inertial frame, you have a weight and the ground is pushing up on you equally and oppositely. So if you're on the Earth, you weigh one amount. If you're on the moon, you weigh another amount. But you do have weight. That's not mainstream physics today. Today, you are weightless. You are in an inertial frame when you're free falling. So as soon as you jump off a cliff, you are instantaneously weightless, and in the inertial, non-moving frame of reference. Now, we know that doesn't go good with a globe model. It's impossible to explain, but let's cover the facts. It's not possible for it to be mass attracting mass. It can't be mass attracting mass. It cannot be a downward pulling force. It can't even be a downward pulling pseudo force. It's easy to show that that's not possible. It's the instantaneous part. So if it was a downward pulling force or pseudo force, then we would register something on the accelerometer until we reach terminal velocity. Or at the very least, we would get some register until we reach 9.8 meters per second. But it instantly goes to zero. So imagine you're on a ride at the fair and you are building up to 1G, or you're free falling and you're building up to reach 9.8 meters per second, starting from zero. Well, until you hit 1G, it would register, an accelerometer would register in between. So from 0 to 1G would be easily measurable, very easily. But that's not the way it works. The accelerometer instantaneously reads 0. There's no halfway between 0 and 1G. So that clearly and thoroughly debunks the possibility of it being a downward force or a downward pseudo force of mass attracting mass. So I'm not proclaiming to be able to show for certain what our downward vector is, but I can show what it isn't for certain. So I've heard people make the claim that the accelerometer is just calibrated at 1G on the ground. It's just due to calibration. And I also thought that. But when you think it through logically, that's not possible. And here's why. That would render drones and all accelerometers completely useless. If it's just calibration and we put it at 0 on the ground, then when we went laterally or any other direction, building up to 1G, it would still be 0. So it would be a worthless unit. If there's nothing between 0 and 0, there would be no half G. Think about it. Their main use is between 0 and 1G. So if it's 0 on the ground, then that means 1G is 0. So you'd have to build up to get to 1G. You'd have to start at 0, build up to 0. So no matter where you set 0, it's going to treat the ground as 1G, no matter what you do with the numbers. So it can't be just the calibration. So once again, what they thought was a globe proof turned out to be a globe proof backfire. Thank you for watching.